Hi everyone and welcome back to our dynamic programming series. We are here back at our beautiful study plan, which is greatly and handsomely created by Leetcode for us. Now, previously we have solved the second problem, the Fibonacci numbers problem, which I intentionally wanted to be the first because I think it's a great example of the other problems and much easier to solve and tackle. Now, climbing stairs problem by default might seem a little bit much more difficult. Let's just close its annoying stuff, but it's in fact extremely easy. So, firstly, let's read the problem carefully. Climbing stairs, we are climbing a staircase. It takes n steps to reach the top. All right, so we have n steps. I'm presuming we have n stairs as well. Each time you can either climb one or two steps. All right, so either one or two stairs at a time. In how many distinct ways can you climb to the top? Now, even though we have this study plan and we have sort of the idea that we will be using Fibonacci numbers, initially let's tackle this problem considering that we don't know that fact. Okay, we can perfectly think about the problem without taking into account Fibonacci numbers. Now, when I see this, I directly go to thinking that it is a math problem. And usually math problems are not very difficult. You just need to take a few examples and tackle them in order to find a pattern, to see exactly what is the mathematical formula in order for you to come up with the answer. Because as you can see here, the input and outputs are extremely easy. You just get n, which is the number of steps, or better said, stairs in your staircase. And then you have to output, yeah, these are the examples as well. N is equal to 2, and you have two options. And when n is equal to 3, we also have three options. Not the most relevant examples, but easiest to follow nonetheless. Now, let's take this problem and break it down rule by rule. So again, we have n steps, and we can climb one or two stairs at a time. So in how many different ways can we climb to the top? Well, firstly, let's also take into account these examples here, all right, which I'm going to also go at our very beautiful whiteboard here. And if we have, so let's say we have n equal to 2, right? Now that means that we have two stairs right here. Not the most beautiful ones, but they'll do. Okay, think. Now we can climb those using one step here and one step here. Okay, keep in mind we can only step one or two stairs at a time and we come to the top, or you can directly go to the top like this. So we have two options right here. Let's say two solutions. Right. Now, let's take the second example where n is equal to 3. Now let's try to break it down by ourselves without looking at the example to make sure that we got it right. So I'm presuming we can go one step here, then one step here, then one step here. So this would be a first. Then we can go again one step here and then two steps here. And the other solution would be go firstly two steps right here and then another one here. So those should be our three solutions. And let me just double check with the problem. So output is three possibilities. All right. Now we cannot count them for every single number of stairs. All right. Working with n, let's say we have 100 stairs. If we try to count them, you might be able to find an algorithm, although highly unlikely and very difficult and definitely not optimal. We want to find a formula, and let's presume we have a huge number of stairs. Okay, so this is what I would think about. Firstly, because we have a huge number of stairs, like this. Let's say this is the first one, second stair, third, and so on. Here is the 105th, 106th. Actually, the number doesn't even matter. 107th, and so on. Okay, let's say this is the last one. Okay, I want to think about how can I find this number? So all of these are variables. We know that in order to get to this stair, you have one possible way. Okay, you just climb one stair. You cannot climb two stairs because you don't have that many. Here we have two options. Here we have three options. If we draw a fourth stair, let's also take this into account. Okay, so if we have 1, 2, this actually might can prove to be a very good exercise. 3 and 4. So also for n equal 4, let's see how many can we count. So this would be one step at a time. Okay, now I'm gonna try using 1 step, 2 steps, 1 step, then 1 step, 1 step, 2 steps. Now I cannot find any more one-steppers regarding the very first stair. So 2 steps, 1 step, 1 step, I presume, and then 2 steps and 2 steps. And I think we have 1, 2, 3, 4, 5 solutions, which I'm quite sure it's the right answer. So right now, regarding the fourth stair, we have 5 possible options. We can also notice a rule. All right, so if you pay attention to the previous problem, which I highly recommend that you see first and foremost, and before we tackle this one, you might already see that here, I'm gonna put this number between brackets, between parentheses. This is actually the Fibonacci number. So if we go ahead and do, let's say, you can make the calculus yourself. So I'm gonna leave this one for you. For n equal to 5, try and see how many solutions would that make. But here, if we talk about not dynamic programming, competitive programming, you have to solve problems quickly. Okay, that's the main issue also when we are talking about interview questions. You want to answer quite robust and quickly. You don't need to be the fastest. You can go with the interviewer through your own head, through your thoughts, show him what you're thinking about. But overall, you want to, at a certain extent, want to make it quick. So right now, we might have noticed this, we might have not. Nonetheless, if we go, let's say we want a general example. We are here. And what would be a general rule? Well, I'm thinking something like this. Here we have, let's say, A numbers. Now I'm going to write it here. So let's say that for this particular stair, very important, pay attention to this. You're not paying attention, but nonetheless, pay attention to this. Let's say for this particular stair, you have A possible ways to reach this one, to reach this particular stair. I don't even care how many, like this, okay? Let's presume that you have the number of ways in which you can reach stair number, whatever this would be, okay? And there are A possible solutions. Now, for the following one, you have B possible solutions, definitely more, because adding an additional stair gives you much more permutations that you have to compute. So for this one, you will need A. For this one, you will need B. Let's also note for this last stair, you would need C number of permutations. Now, we don't really care about these numbers from 1 to B. We don't. We just have to use them in order to reach C, because C is the number that we are looking for. How do we do that? Well, I'm thinking to exploit this rule. So this is a rule that is exploitable, a piece of information that gives me a lot of possibilities, all right? Because every single line that the problem gives you can point you toward a certain solution. So every time you can either climb 1 or 2 steps, okay? So because I can climb 1 or 2 steps, for example, let's say I am here from A, right? in order for me to reach from A to C, I just need to make a 2 stairs leap, right? So I just need to climb 2 stairs and I go from A to C. And going from this stair to this stair directly, all right, so not going through B, can be done in A times plus 1. No, sorry, exactly A times. Because if I have A or X, whatever you want to call it, a number of possibilities to go from level 0 to, let's say, level 100, well, then we can make this leap at the end of all of those A combinations, permutations, and we reached C, right? Now, we also have one more possibility. So again, how was I thinking? How do I reach the last step? How do I reach this very last stair? Well, I can reach this one by either jumping from here or coming from here, because I can either do 1 or 2 steps. Again, take into account this solution that jumping from A to B and then from B to C doesn't count. Why doesn't it count? I'm going to leave it for a second. Write in the comments down below who got it. All right, time's up. The solution is that this doesn't count because if you go from A to B, now this includes that this is included in this scenario here. If you jump from B to C, okay, we talked this. I mentioned this previously. You can reach the final step by going either from the previous one step or the one before it 2 steps. So if you go to A to B, this possibility, this permutation is already found here, going from B to C. Okay, so this is why we don't take into account this road. Now that's a little bit tricky, but you can make a few examples and try to understand and visualize better what I'm talking about. Now, if from A, I have only one possibility of going from A to C, and from B, I have only one possibility from going to B to C, then all of these permutations, they just add up. So basically, I get that C is equal to A plus B. And this is actually the formula that we will be using throughout the solution in order to build a solution. And if you want to find that out, we can actually try it right here. Okay, so let me show you again using this example, all right, before writing the code. So I have 1 stair, 2 stairs, 3 stairs, and then 4 stairs. Okay, so we presume here from our general example, okay, that C will be equal to A plus B. Well, let's say we are here and we know that we have 2 possible solutions in order to reach the second stair, right? Now, to get from the second stair to the 4th stair, we just go directly using a leap, okay? And we get 2 solutions. The 2 solutions from here that I replicated using a 2-stair leap moves us from stair number 2 to stair number 4. All right. So from 2 going here, we have 2 solutions. Now we will need to add all the solutions that moves us from stair 3 to stair 4. So right now we have to permutate here all possible solutions that moves us from level 0 to level 3, okay? Because to level 4 we only add 1. Right now we cannot jump 2 stairs from stair 2 because we already taken them into account. So in how many ways can we go from level 0 to level 3? Well, exactly these 3 solutions. It's like this. So it's 1, 2, 3 and then move to 4, but we don't care about that. Okay, we take this let's say row that's granted. We can either jump to here and move 1 here as well, or we can go 1 here, jump to here, and then we don't care above. So 1, 2, and 3 possible ways. So 2 plus 3, it's actually equal to the 5 permutations that we got beforehand. Okay, you got the grasp of the idea? Well, now having this in mind, and now that we have figured out that we can know the number of ways in which we can find or we can reach stair n or stair x using the 2 previous ones, we just have to implement that into code. Now this should be really straightforward. Okay, we need to take into account the edge cases. So I'm looking at constraints first and foremost. 1 needs to be lower or equal to n, lower or equal to 45. I presume integers should be enough for this problem. Now, in case 1, we have to take into account the very first example. So if n is equal to 1, this should be an edge case. So we have to just return 1, which is the answer, because if you have only 1 stair, the only solution there is just climb 1 step. Just do 1 small step and you are on top of stair number 1. Now we don't need to use an else because, well, if n is equal to 1, it will just return and end the function. If it's not equal to 1, then we'll move on. So right now we only need to take into account the previous and current stair. Why? Because if we have the previous stair and then the current number of stairs, the following one will be equal to the sum of these two, and then we can update the previous variable with the previous current one and the current one with the actual current one. Okay, so actually you can write this code in a multitude of ways, but the idea will be the same. So I'm gonna keep in mind the previous stair, which is equal to 1, and then the current stair, which is equal to 1 as well, because I'm presuming we are starting with like the Fibonacci number with 1, 1. Although here it's 1, 2 directly, but nonetheless. So for we need an index equal to 2 because we already tackled the scenario where n is equal to 1. All right, our index has to be lower or equal to n, and we have to increment our index after every iteration. Nice. Now, yeah, here we'll also need a temporary variable. So our beautiful temporary variable has to be equal to the current one because we have to remember the value, okay? Basically what we want to do, so we know A and we know B. We know the previous one and we know the current one. So because we just know A and B, and right now we need a temporary variable, all right, to store B. After that, we can compute C using A plus B. So we compute C here using this variable, the current one. So we don't know B any longer. We have this temporary variable that will be our old current. Now, previous will need to take the value of B because right now we have C stored here, and we will need our new previous B stored. Right? Now, again, you can write this code in a multitude of ways, but just because we solved the previous problem using 2 variables and we name them behind 1 and behind 2, right now I want to write the code slightly different. Current should be equal to the previous number of possibilities plus the original number. Okay, so we have just compute the following stair, so the number of computation for the following stair. And right now that we have all permutations, we also have to take the variable for our temporary variable and make us our current previous variable. Might be slightly confusing, but you can write it down, look at it a little bit, and so it will make sense nice and easy. And we have to return the current because inside of the current variable, we store the current number of permutations in order to reach the staircase n. Now let's presume that everything is fine. Give it a quick run. Well, apparently we didn't mess up any indexing. So submitting the answer. And apparently we get a very good runtime and very good memory. Nonetheless, don't worry if you don't get perfect runtime. Again, Leetcode messes them up and sometimes, and you might get random values. So it's not really, really important. If you want to make your very own benchmarking, don't worry, we'll do that in another video and show you exactly how to measure your code's performance. For now, at least we have to focus on solving the problems and then optimizing and deeper doing benchmarks on your code. Thank you for watching and see you in the next episode. Bye.